Hi students, in this video I want to explain a little bit about friction. So let us think that we have a block of mass m here, and then we have a force F acting on this block. This is maybe your hand pushing the block, right? And then due to the interaction between the regularities of the surface of the block and the surface the plane where the block is moving, we're going to have a force of friction. And this force of friction is going to be a force with a direction opposite to the direction of the force F. Now, as I have explained in my lecture, uh, we have two different type of friction. So we have two different type of coefficients of friction. We have the coefficient of static friction and we have the coefficient of kinetic friction. We're talking about static friction when the block is not moving yet, right? So you are applying a force, but the block is not moving because there is a force of friction that have a direction opposite to the direction of the force that you apply. That then it's just keeping the block at rest. As you increase the magnitude of the force that you apply, eventually that force F, that external force, will be higher in magnitude than the static friction force, and then the block is going to start moving. And once the block starts moving, then now what are we going to have is just a force of kinetic friction, right? So always the force, the coefficients of static friction is higher than the coefficients of kinetic friction. So let me say that we have a coefficient of static friction of 0.7. We have a coefficient of kinetic friction of 0.4, right? And let us think that the block has a mass of 6 kilograms, right? So let us think that we are applying a force F equals to 10 newtons, and we want to know if with this force of 10 newton, this block is going to move or not, along this surface. So the first we have to remember is that as this block is resting, on the surface, there would be uh, a reaction that is going to call the normal force, N or Fn. You know, there is in some way an action-reaction pair with the weight of the block in this case. So the weight of the block, that is due to the effect of the gravity, point toward the center of the earth, or in this case, point, vertically. So it's going to point always vertically down, right? And then in this case, the normal force, so as we have a flat surface, with no stiffness, right? So we're going to have the normal force have a direction opposite to the weight and is equal in magnitude. So the first we want to calculate, right, if we are going to find the force of friction and to know, if the force F is large enough to make this block to move, it's going to be the weight. So we calculate the weight, and the weight is equal to the product of the mass times the gravity. So we have a mass of 6 kilograms. I will take the gravity equals to 10 meters per square seconds. We know that it's 9.8 meters per square second, but we're going to take 10 meters per square second to make easier the calculation. So we're talking about 60 newtons. So this is the weight, 60 newtons. And it's a force that points downward, right? Now, we can calculate now the normal force, and in this case, we know that the normal force is equal to the weight. So the normal force would be also a force of 60 newtons, but the normal force would be a force pointing outward, right? Now, once we know the normal force, we know that the force of friction, in this case static, is equal to the coefficient of static friction times the normal force. Since the coefficient of static friction is 0.7, and we said that the normal force is equal to uh, 60 newtons, when we multiply, we have here 6 times 7 is 42, so 42 newtons. So this is the force of static friction. So what it means that we have our block under these systems of forces. We have a force F here that have 10 newtons, right? And we have a force of friction that have 42 newtons. This would be the maximum value that the force of static friction can reach. Because let me explain something. The force of static friction can go from 0 to a maximum value. This is for the force of static friction. So when you apply 10 newtons on the block, the force of static friction that opposed to this force of 10 newtons has also a value of 10 newtons. You increase the magnitude of the force, right, to 20 newtons, to the external force to 20 newtons, and then, you will be, you will find now here that the force of static friction have a magnitude of 20 newtons also. You increase a little bit more the external force to 30 newtons, and the force of static friction increased to 30 newtons. You increase now the force of F, the external force, to 40 newtons, and then the force of static friction increased to 40 newtons. But now when you apply 45 newtons here, you apply now here 45 newtons, right? Now these 45 newtons are greater than the 42 newtons, that is the maximum value of the forces of static friction. So the force of static friction can go up until 42 newtons. But once you apply 45 newtons, your external force is greater, and then there will be here a net force acting in the direction of the force of 45 newtons. That is going to be equal to 3 newtons, because it's the difference between the force you apply minus the force of friction here. And the block is going to start moving with some acceleration, because according with the second Newton's law, there is a relation between the force and the acceleration, such that force is equal to mass times acceleration. So you can find then the acceleration. So it's not going to be a uniform motion. It's going to be a motion with acceleration. So this is something that I want to explain. So if you ask, what is going to be the minimum force needed to make this block to move, right, due to the action of the force F, what is the minimum force F that is needed? Well, the force F have to be greater than 42 newtons. That is going to be the maximum value that reach the force of friction. So remember that these value go from 0 to a maximum, right? So here, this value is the maximum value of the forces of static friction. Now, I think you understand that if we apply just a force of 10 newtons, this block is not going to move. If we apply a force of 45 newtons, this block is going to move, right? And that the force of static friction is going to be increasing as you increase the external force, F, that you apply on the block. So only when the magnitude of the force external is greater than the force of static friction is that this block is going to start moving. Now, once the block starts moving, if we want to calculate the force of kinetic friction, This would be the coefficient of kinetic friction times the normal force. So the force of kinetic friction would be zero point 0.4. That is the magnitude that I gave you for the coefficient of static friction times the 60 newtons. That is the normal force. So we have, in this case, 24 newtons. So once the block is moving, it's enough with a force of 24 newtons or greater than 24 newtons to keep it moving. So you can now decrease the magnitude of the force that you apply, right? You can decrease now the magnitude of the force that you apply, and this is going to be moving anyway, right? Why this force is still be greater than 24 newtons. So this is, what we have to know about the block or an object that is sliding above a surface where we have that means we have a force of friction between the surface and the block, right? So it's not a frictionless problem. So we know now how to find the weight, how to find the normal, how to find the forces of the friction, how to find the force of kinetic friction, and we now can also understand, when the block is going to move or not, what is needed to make this block to start moving. So thank you for your attention to this video.